Hello, welcome back. This is lesson 13, part 4 of a series on building a program. And what I like to do in this lesson is finish up looking at int 16, the bias interrupt for keyboard. And instead of, I won't do the DOS fix yet. There are a couple other things I'd like to do first. And going back to our lesson plan. So I want to get to this part before looking at DOS. Okay, so save. Sorry about that. Find out what that's supposed to be. Yeah, 1 over and n is 1. Alright, sorry about that. So where we were was we read a key from the keyboard. Now, I don't know if you noticed last time, I will do it again. I notice a lot of times some of the things I say aren't getting out on the microphone. I want to move to a high 0 in 16 and then nothing. Oh, I put an interrupt here. I put a breakpoint. So we'll do that again. Breakpoint. And just go. And I type the letter B and send. Now I'm going to point out how if you were very observant, may have noticed that the B came back and it's in the AX register there in the scan code and everything, but there's no B on the screen. So there are two possibilities. One, maybe it came out and it got mixed up with all this debug register output. Or it just didn't, we ate it up, so to speak. Okay, the key never made it to the screen because it never got to the code that would normally print it to the screen. So in order to prove that, and also show you something else, so I'm going to turn this our 2-line program into a real program like this. Here's our program. It's got two instructions. And take away the breakpoint and replace that with a quit. So at 104, put in an int 20. So now if this were a program, it would quit after doing the int 20. So what we have now is a 6-byte program, and it's easy to see how big it is by checking the last line. So it's 6 bytes, and we would like to take this and turn this into a real program. And when we do that, let's first think of a name for the program. And I'm out of ideas, so I'm just going to call it int 16 function 1 specific function 0 dot com dot a command program, com program. Now, that doesn't mean that it's done. That doesn't mean we made it yet. All we've done is we've given the debug program a name for this program, and now we're going to write it out. So we want to specify how big it is. Do that. We put the size into CX, set the registers. I'm pretty sure it uses both BX and CX in size. So BX is 0, so we're okay. Lastly, if I type W, it says it has written 6 bytes. Click the directory, and there it is. The program. So I'm going to run the program now from here and see what happens. Now I just have to click the program in. Running, waiting for me to type something. And I type something, and you see nothing came out. Alright. So, I think, even if it's still not 100% certain, I'm pretty sure our program ate the key up. There's a third possibility, but I won't go into that. The second function in that list on 16 hearing solving. The second one is a check. This function, function 1, if we call it, again, this is assume we're going to type in 16. If we put a height equal to 1 instead, once it comes back, if the 0 flag is set, then there's nothing available to read from the keyboard. If it's clear, there is a key available. And it tells us, also tells us the key is, exactly like the first function, but this one doesn't read it out. So this is a way of checking the keyboard without eating. This would be like peek, peek at the keyboard. This is like a poll. There's a poll in the keyboard that says, try and make program this function. So we want 1, comma 1, move an A high 1, if you are in 16, but now according to the document, according to this thing, according to this thing, it's the 0 flag. If it's no 0, if it's 0, so if it's set, there's no key. If it's unset, there is a key. So that means that if it's 0, there's no key. No way to check and jump at the same time, as you recall. No, actually, I didn't tell you this one yet, so I'm doing a new one. Jump, if the 0 flag is set, I'm going to say jump, that means no key, back to 100. So, if there's no key, this is a loop. We'll run through the same code again, and eventually, when somebody presses a key, the flag will get unset, and it'll go to the next line, where I'm going to put an exit program, and we'll be done. First, let's make sure we can't. Well, we can test this. But let me just first test it. this way. And I proceed over this interrupt column because that's long story. And like anything, big procedure. I can use trace for the little ones. It went back to 100, so that meant there was no key. Pretty easy to see. Now, repeating what we did, put the 1 in there. See how it only moved the 1 in the top and not in the bottom? Proceed over length 16. And you take the 0 flag. If it's 0, go to 100. Go to 100. And it keeps going in this loop. Now, I can't do two things at once. Eventually, I've got to let it start going through the loop on its own and wait for me to type a key. I can't type trace, and have it wait for me to type a key at the same time. Eventually, I've got to type go. So I should have put it in a breakpoint, but this is good enough. And type go. Alright, so here it is, waiting, polling the keyboard. This is what they mean when they say polling. We're checking. Each check is called a poll. Now I'm going to type my letter B and the program to quit. And it did. Now, look. Now here's a B. That's the B that I typed. But trust me, I didn't type it. I typed the B when we were up here. Then the program ended, and now there's a B here. So the question is, how to get there? Well, that's not too hard to figure out. We checked and checked. We saw there was a key available, and then we quit. We didn't speed it up. So after the program's finished, control was returned back to debug.com or whatever it is. And then the debug program discovered, there's a B ready for me to read. And it read it and printed it out. So the debug program printed this out. I typed it. And the debug program read it just as if I typed a B now. It reads it and prints it out. Okay? Now again, lost it. Let's start over again. We can turn this into a program. In 16. Go to 100 as long as the 0 flag is set. Otherwise, put the program. And this program needs a name for it. Talking 16.1.com and new type program updated here. Write it out. And do that again. And there it is. And run the program. Okay, so just like before, it's waiting for a key. Okay. Try another letter. You create it. Take a walk on the wild side. Z. And there's our Z. Okay, so real quick, when I saw the Z, control was returned this time to the operating system. The operating system, this time rather than debug, noticed, there's a Z in there ready for me to read. It read the Z in just as if I type 1 now and printed it out on the command line. So what we have invented in a sense are the C functions. You can call them C. There are two functions in the called console input output set of functions are all in this header file. And there are two functions for both declared as end. So one of them is called get. Now actually, nowadays, we put an underscore. And if you look at the help, it says waits for a key to waits until a key is available and returns the value. It returns the value. And the other one called get key, and this one says waits for the keyboard to be available and returns the value, echoes the value on the console. So in a sense, we've written these two programs. We could, if we wanted to, rename. I never showed you this, but you could have found this in the help. You could rename this. Actually, small letters looks like color, isn't it? And it's all this get. Rename. All there. So now, I renamed it, so now we have the get functionality available, and the get function available. Okay, enough of that. Now it looks like we're starting on what we want to talk about anyway, functions. So now this will just take up the rest of the time. I'm going to pause here a minute, look stuff again, and just need to do something quickly. Sorry about that. Okay, I paused and I noticed that I used up 20 minutes already. So call this the end of this one, and I don't know, resume the next tutorial. Functions. We're going to go on to functions. Okay. Alright, see you next time. Bye.